Hello, in this video we will talk about the OASIS library, which is fundamental for building your own OASIS application, and the naming conventions used in OASIS. And we will start here with the naming conventions. OASIS itself, this acronym stands for the Open Underwater Acoustic Software Defined Integrated System, or in short, a architecture for building underwater acoustic devices. So OASIS, when you hear that, refers to the architecture for underwater acoustic devices such as OASIS DeckBox, OASIS modem, OASIS navigation system, and so on, similar to how you might say, oh, this is an Android phone. We also use the OASIS designator or name to refer to the OASIS library as a whole. So you will see a file oasis.lib, and then as namespaces within the library, OASIS chip, OASIS board, etc. Moving on to products here. Products under OASIS have their own names. For example, ASAM is the Environment Adaptive Simple Acoustic Modem. That's a wideband software-defined acoustic modem for defense applications that we developed under a DARPA contract, R&D contract, and it's really the foundation of OASIS. Now, at first, we called everything ASAM, and you might still see that in there. Then we realized that's kind of confusing. So now the architecture is called OASIS, and ASAM would be a modem. Then the commercial modems have a different name designation, SAM2. So you know, well, ASAM is ITAR controlled stuff, but SAM2 you can use in commercial applications. Then there's other projects in progress, such as the Universal DeckBox for ropeless fishing inspectors. It allows ropeless fishing inspectors to raise ropeless fishing gear for inspection, and that gear can be from any manufacturer, any model, using any uh, acoustic communication protocol, and over time we'll come up with more products here. Let's move on and look now at the structure of the OASIS library, and it's kind of built in concentric ring, where an outer ring builds on stuff that's in the inner ring. I also indicated the namespace conventions here in red, and I should have really put OASIS here at the core, and core functions are things that are least hardware specific, not at all hardware specific really. They include things like CRCs, for example, or binary search or convolution, and so on. And then chip level stuff builds on top of that. It might use some of the core stuff or not. So chip level device drivers. And then board level stuff builds on chip level. So here we go into things that are specific to a board that use chip level functionality, but they are specific to the board. And then a new thing that we just did is we have these application support functions. There will be many in the future. In the first version of the library, it's just, you'll see that as ACP, Acoustic Communication Protocol. And all this is encompassed by the library, or the library consists of all this, might be a better way to say. And what you'll be coding in is the application layer primarily. Here is another representation of this. Here it says, oh, core is most project agnostic. Means it's not specific to a project, could be used anywhere. And then as you go through chip and board, and then the application layer is least project agnostic, kind of a weird terminology, most project specific, I would say. Looking at the file structure here, you would have application specific code, like for the ASAM modem or UDB here. It makes use of the library. The library breaks down again into core chip boards, and then some of them, chip is right now just a MSP 430 FR5994, but different chips may be used in the future, and boards is the EM60 and CTAC devices, and so on. With that, let's now move and have a look at Code Composer Studio, Texas Instruments Code Composer Studio, what the library looks like in the structure of the files here. Here under third party, we have things that are not from Desert Star, they are from TI. So these are the headers for TI provided driver functions and such. Debug is not used. That would be your debug branch of a working application, but this is really just a library here, so it's no working application. Then under docs, we have the OASIS manual, so you can look at the manual, and it's based on Doxygen, so it has all the comments that are associated with the header file primarily, plus some additional content in there as well. Here's the library itself, oasis.lib, that gets linked with your source code to build the full application. And then under the source folder and OASIS subfolder, we again have this structure of different layers. Now, legacy here is actually C code that we developed originally for the EM60, and some of the core chip and board level stuff makes use of the legacy stuff here. But generally you won't be working with that. Here we have core. You see again, like here, CRC, convolution, binary search, some benchmarking, and so on and so forth that's available here. Then on the chip level, it's specific to the 430FR5994 variant. And we have stuff in there like timer, power management, oscillator, clock oscillators, and then LEA is the low energy accelerator. It's the DSP coprocessor. Currently we have FFT and FIR function in here. Here's a way to do DMA-based data streaming, which is used for the acoustic data stream. Crash detection, also sometimes called the COP, computer operating properly, analog to digital, and a few other things. Moving on to the board level here, we have serial communication and LED here, and you might go, well, serial communication, isn't there an SCI in there, an SPI, and yes, there is, but it's hooked up. The individual ports are hooked up to board level hardware, such as an RS-485 driver or USB driver, and that makes it board specific. Same with the LED. Yep, it's just a GPIO line of the MCU, but it's a specific GPIO line that drives, or two specific lines that drive the two LEDs there. So that's why that's on the board level. Acoustic communication, how to operate the acoustic transmitter, the low frequency receiver and the high frequency receiver on the board. And then building on that, when you're building in an underwater acoustic communication application, you have ACP functionality, acoustic communication protocol. Here we have FHPP is a specific protocol that's implemented. We already have several other ones like Janus. They're not in here yet because we haven't sufficiently validated them yet. So we will add that in the new version of the library. Then packet is some acoustic data packet definition. So we consider data to be always transmitted in packets, even if the packets can be very short or have more information in it. And sort of protocol, acoustic protocol stuff that's generic rather than for a specific protocol. So this is the OASIS library structure, and you will use that then to code your application layers. And in the next two videos, you will see how to first code a very basic sort of a hello world application. And then we move on to a more advanced application that actually does acoustic signal processing and analysis there on the receive end, and then acoustic transmissions as well. Thank you. Thank you very much.